Welcome to the Högdalen Heat and Power Plant, one of the world's most modern plants for waste combustion. In actual fact, it's in the Högdalen Heat and Power Plant where Stockholm's waste is converted into useful energy that will benefit Stockholmers in the form of distance heating and electricity 24 hours a day, all year round. The Högdalen Heat and Power Plant constitutes the basic production in Stockholm's southern district heating network. We produce 1,700 gigawatt-hours of heat here, as well as 450 gigawatt-hours of electricity a year. The hub of our operations is the control room from where the heat and power plant's various combustion and flue gas purification processes are controlled. And this is where it is ensured that all customers get heating and that all the environmental permits are adhered to. The Högdalen Heat and Power Plant comprises two blocks, one for household waste and one for industrial waste. For household waste there are 4 grate-fired boilers with a total of 171 megawatts, and for industrial waste there is a 92 megawatt circulating fluidized bed. The machinery also includes state-of-the-art flue gas purification equipment, 2 steam turbines and an oil-fired boiler for peak load. The Southern District heating network extends from Södermalm to Farsta. This means a total of 800 kilometers of piping, which contains 42,000 cubic meters of hot water. The network also includes other production facilities such as the Hammarby heat plant and Årsta heat plant. The Högdalen Heat and Power Plant is one of Europe's biggest refuse incineration plants, to which over 200 fully loaded refuse lorries containing household and industrial waste come every day, delivering fuel for the boilers. Every year, Stockholmers deliver 230,000 tons of household waste. During the time the Högdalen Heat and Power Plant has been growing, the surrounding municipalities have also started delivering their waste to us. The catchment area now covers pretty much the whole of the county of Stockholm, which means about 500,000 tons of waste a year. The lorries empty the household waste into a large bunker. In the bunker, the fuel is processed with the aid of overhead travelling cranes. The crane driver in the crane cabin has 3 important tasks. The fuel must be moved away from the tipping hoppers, mixed and finally lifted into the fuel funnels that feed the boilers. The fuel then proceeds through the shaft down to the feed table where hydraulic pushers feed the fuel according to the power requirement. The grate boiler comprises a drying zone, a combustion zone and final combustion. When the material is burnt out, the residue or clinker drops into the clinker extinguishing vat, after which it is fed into the clinker bunker. The clinker is then taken to a disposal plant where it's recycled. The scrap is separated off using a magnetic separator, and the residue replaces virgin material for covering and wall construction at the disposal site. The oxygen from primary air brought into the grate from below makes the fuel burn. The hot gases move upwards in the body of the furnace, where more oxygen is added in the form of secondary air for complete combustion. To reduce the nitrous gas emissions, ammonia solution is added in what is called an SNCR system. The body of the furnace is made up of tubes in which the boiler water is evaporated by the heat from the combustion. The hot flue gases are further cooled down in the idling duct before they continue to the superheater pack, where the steam is heated up to 36 bars and 380 degrees Celsius. The heated steam is taken to the works' main steam pipes, where it drives turbines to produce electricity and is heat exchanged with the district heating network in condensers. The heated water is pumped out into the city to heat dwellings and industrial premises. The cooled district heating water is then returned to the works to be heated up again. The waste producers thereby get back the energy from their refuse and the cycle is completed. After the superheating process, the flue gas is still at around 300 degrees Celsius. Further heat is then extracted by heating the feed water in the economizer pack. The flue gases have by then cooled down to about 160 degrees Celsius and continue to the flue gas purification plant. first stage of purification comprises an electrical filter whereby the fly ash is separated off. The ash is transported dry and in a sealed state to a mixing station at the disposal site, where it's stabilized to form cement blocks to avoid leaching of heavy metals into the surroundings. The flue gas purified in the electrical filter is taken on to the wet purification, where it is washed with liquid in 2 stages. The first scrubber is acidic, pH 0.5, and chiefly separates off chlorides, heavy metals and residual ammonia from the SNCR system. The second scrubber is neutral and separates off sulfur. The wet purification uses calcium carbonate and activated coke as reagents. Downstream of the flue gas flow there is also an electroventuri that acts as a so-called police filter for dioxins. The energy present in the steam component of the flue gas is then extracted by means of condensation. Further energy is thus utilized for the district heating network. The flue gas fan helps the flue gas get through all the components and into the chimney. In the chimney, the emissions are continuously measured and monitored from the control room. The purification requirements for waste combustion are very stringent in terms of both national and European legislation. All lines in the Högdalen heat and power plant meet the emissions requirements by a clear margin, which is the result of a long-term strategy for sustainable development. The Högdalen heat and power plant has a total of 6 boilers. 4 are fired using household waste, 1 by bio-oil, and then the 6th boiler, which is fired by industrial waste and has its very own production line. Boiler 6 has an output of 92 megawatts. As already mentioned, the boiler is fired by industrial waste consisting of sorted and crushed fractions of paper, wood and plastic. The fuel is emptied into its own stoker hopper for transport onto 2 large storage silos, where it is then automatically conveyed into the boiler via 3 independent fuel lines. The actual mode of combustion is virtually the same as for household waste, but there are a few differences. The fuel is fed into a fluidized bed via 3 fuel screws. The bed consists of inert material that is fluidized using primary air via nozzles at the bottom of the furnace. The fuel dries and is expelled very quickly due to the high heat transfer in the bed. Post-combustion takes place using secondary air immediately above the bed. To reduce the nitrous gas emissions, ammonia solution is added in the SNCR system. Inert material follows the flue gas into the cyclone, where it's separated and returned to the bed via the Intrex heat exchanger after the sand seal. The body of the furnace and separator are made up of tubes in which the boiler water is evaporated by the heat from the combustion. The hot flue gases are further cooled down in the idling duct before they continue to the superheater pack, where the steam is heated up to 60 bars and 480 degrees Celsius. The clinker is fed out from the base of the boiler and conveyed to a clinker bunker. The Högdalen heat and power plant is a modern workplace that is constantly being updated. These archive pictures, taken 35 years ago, highlight how the waste industry has developed. The problem of growing amounts of waste in metropolitan regions became increasingly urgent in the 60s, and in 1963 the City Council resolved that a new plant would be built beside the Högdalen peaks. In 1970 the Högdalen power plant was then commissioned. At the time it comprised 2 combustion furnaces, each with a capacity of 15 tons of waste an hour. Even then the works was a modern workplace with the latest technology. Flue gas purification using electrical filters and energy recycling in the form of electricity production with the aid of a turbine. In 1979 the heat and power plant was connected to Farsta district heating systems. In connection with this, a liquid fuel boiler producing 80 megawatts and 2 20 megawatt hot water boilers were built to handle high load periods in the network. Heating needs in the region grew and 3 years later an electric boiler was installed. In 1986, combustion capacity was replaced in Lövsta by a new waste-fired boiler, Boiler 3, at the Högdalen Heat and Power Plant. Flue gas purification was installed with this boiler in the form of lime reactors and cloth filter collector. As the plant expanded, the workforce also grew. In 1987, a new office building was constructed, and the following year, the flue gas purification for boilers 1 and 2 was upgraded to the same standard as Boiler 3. In 1999, the Högdalen Heat and Power Plant started using a new fuel, PTP, consisting of sorted and crushed fractions of paper, wood and plastic. The CFB circulating fluidized bed technology was used here. The plant was equipped with both semi-dry purification and wet purification with flue gas condensation, and as with the upgrade in 1988, the existing boilers were also enhanced with wet flue gas purification and flue gas condensation. A new turbine was also installed along with Boiler 6 in 2002. Additional expansion in the form of a new grate-fired boiler for household waste, Boiler 4, was approved at the same time. As part of the preparatory work, Boiler number 5, the oil-fired boiler, the ash handling and ammonia tank were all moved to make way for the new boiler. In autumn 2004, the new boiler was put into use. Thus, the Högdalen Heat and Power Plant now has a total combustion capacity of 700,000 tonnes of waste a year. 100 or so people currently work at the Högdalen Heat and Power Plant, making sure that the waste in the Stockholm region is utilised in an environmentally correct manner and is returned, refined, in the form of electricity and heating to the city's inhabitants. In other words, the Högdalen Heat and Power Plant is an important part of the city's infrastructure, and together with Stockholm City, Fortum ensures the functioning of the cycle now and in the future.